Welcome everybody. Thank you for your kind attention this afternoon. This topic is about Mathemachines via Lego, GeoGebra and CindyJS, a bit of mathematics education and computer algebra, kind of mixture of two topics. The abstract I would like to shorten a bit, so it's about mathematics education and gifted students. We like to connect symbolic computation and dynamic geometry by using three different digital tools, namely Lego Digital Designer, GeoGebra and CindyJS. The aim is to teach algebraic curves and geometric loci by using these three tools. There is a story behind. Let me quote campus paper actually on a general method of describing plane curves of the nth degree by link work, a 19th century work. Until 1874, no one in England knew of a method for drawing a straight line that was, in principle, perfect. The first solution was found by a French army officer called Poisselier and was brought to England by Professor Sylvester. And these three people, I need to name two other people, namely Lipkin and Chebyshev. They did the same work like Poisselier independently, and their work was recognized just later. Another very famous and important person in this story is James Watt. James Watt was actually an 18th century scientist and researcher, and he already knew how to draw an almost straight line. An almost straight line means, from a technical perspective, it could be a kind of problem. So there's a sketch that shows how easy is it to create actually such a kind of linkage, and that's how we start the story from the educational point of view, because if it's easy to do, why not do it at school, in a classroom, with children, with young learners, because it can be done, and the process how the mathematical background can be developed is actually possible to do. This is how you can use Lego bricks to create a kind of Watt linkage, and how you can draw this interesting curve called Watt's curve. We can do the same in a demonstration video. One on the left is Watt's linkage. Watt linkage is used in a car suspension, and possibly a Lipkin linkage in kind of perpetuum mobile. So three digital tools are demonstrated. Some detail on the mathematical background. Well, it's the Watt's linkage. Point A and C are fixed, and there are three other points. MN, FG and XY are these three other points, where XY is the midpoint of the other two, and the length of these yellow bars are fixed. Also the gray bar is a fixed one, its length is fixed. And we can learn by using only the Pythagorean equations and nothing more, so it's doable in school as well. So these equations are very simple if we eliminate all variables but x and y. This is performed in this case by GeoGebra and its embedded computer algebra system GeoC. Then we can obtain well, actually an ideal that is a principal ideal that is generated by a polynomial. And in this case, if we find a geometric set of the algebraic variety. We can go one step further. If we create the same thing in GeoGebra by let's create the same construction in GeoGebra by using so-called geometric steps. Then we have the opportunity to, well, change the parameters. It means that we can not just change position of this point T when we change the position of M of a mover, and T is a tracer in this case, but we can also do some computer algebra manipulation in the background. If I change the position of this point, if this end point, then I will have actually a changing equation on the bottom here, and I can do the same for the position of C, or if I can do even a longer segment for G, and finally I can create very interesting inputs that are completely different from the starting setup. So for example, in this case we have a union of three curves, three circles, and it's also very interesting from the educational point of view how we can factorize this polynomial that is the output of the computations. Actually, I managed to do this with a couple of students this year in February, and the students had to explain the topic to the audience, including their families. This is a shopping list if you want to join in some sense. Well, I would like to show you how the Lego digital designer can also be used. We also used it in Kefarmarkt in the Project Week camp. This is not the Poisselier linkage, it is just the Poisselier cell. This part is missing because the students had to learn actually the idea that if you fix this point on a circle, if you if you constrain this point on a circle, then you can actually constrain this other point to move on a line. Why? Because this so-called Poisselier cell is only for inversion, but if you put the input circle in an inversion, so I mean this circle here, then you will be obtaining actually a line. So this is the story, this is the mathematical story in the background. We discussed the same thing in a GeoGebra applet, namely in this one. So we have a so-called reference circle, and we are interested what happens if we have say a set of lines. So this line has an image blue circle, and if I change the line, then the blue circles are also changed, so we can have actually a large set of circles as outputs. Well, you can see that here my own person was used to explain the concept by using CindyJS. The reference circle, this is the reference circle of the inversion, circle inversion, and by pressing I here I can do circle inversion on the whole input image. If I press it again, then I will get the original image, and if I move myself, so up and down, this is the input. If I change the output to be not the simple output, but after circle inversion, then it looks like that. So this is how it works. this is how the lines will be changed to circles. The end of the story can be summarized that the inverted image of a circle that is going through the origin of the circle inversion is a line. Conclusion: teaching algebraic curves for kids is possible and it is fun.